Stateside Ledger presents The Dark Side of Frypans. You use it almost every single day. Eggs in the morning, chicken at night, quick meals, no stress, no sticking. But what if something that ordinary carries a story most people never hear? For decades, one of the most popular kitchen tools in the world has been at the center of lawsuits, scientific debate, and environmental investigations. And the strange part? Many of the concerns didn't start recently. They started decades ago. Tonight, on Stateside Ledger, we're breaking down the hidden story behind non-stick cookware, the science, the chemicals, and the questions still unresolved today.
Welcome back to Stateside Ledger. In kitchens around the world, the frypan is a symbol of simplicity. It's fast, it's easy, it makes cooking accessible. But behind that convenience sits a complex industrial story, one that connects chemistry labs to manufacturing plants to everyday kitchens. And to fully understand it, we have to go back to where it all began. In the 20th century, a breakthrough material changed cookware forever. It was called PTFE, a synthetic polymer designed to resist heat, friction, and almost everything else. It later became widely known under a brand name, Teflon. The promise was simple. Food wouldn't stick. Cleaning would take seconds, and cooking would never be the same again. But the manufacturing process behind this innovation relied on chemicals that would later become highly controversial. One of them was PFOA, a compound used in production that later drew attention from researchers and regulators. Because, unlike many substances in nature, PFOA does not break down easily. It persists in water, in soil, and in the environment. And over time, concerns began to emerge about long-term exposure. Research linked it with a range of health risks, including potential impacts on cholesterol levels, thyroid function, and certain cancers. But at the time, much of this information was not widely known outside scientific and industrial circles. And that gap between research and public awareness is where the controversy begins. By the late 20th century, communities near manufacturing sites began reporting unusual environmental concerns. Water contamination, livestock effects, and health patterns that drew attention from researchers and legal investigators. One of the most well-documented cases involved long-term legal efforts that challenged major chemical manufacturers. Internal documents later became part of public investigations, and what they suggested was uncomfortable. That some risks may have been understood internally long before public awareness caught up. This wasn't just a cookware story anymore. It became a story about industrial chemistry, regulation, and how long it takes for scientific concerns to translate into public action. Eventually, PFOA was phased out in the United States, but that wasn't the end of the story. It was the beginning of a new chapter. Today's cookware looks safer, cleaner branding, PFOA-free labels, new chemical formulations. But the core question remains the same. What replaced the original compounds? Many modern coatings use alternative substances designed to achieve the same nonstick effect. And while these replacements are marketed as safer, scientists continue to study their long-term environmental and health impact. This is where complexity enters the picture. Because in science, not fully proven harmful is not the same as proven safe. And the gap between those two statements is where consumer confusion lives. Beyond chemical composition, there is another factor that often gets overlooked: heat.
Nonstick coatings are designed to perform within specific temperature ranges, but when those limits are exceeded, the material can begin to degrade, releasing fumes that may irritate respiratory systems. In controlled studies, high overheating conditions have been associated with short-term flu-like symptoms in humans, and in extreme cases, they can be harmful to small pets with sensitive lungs. But here's the real-world issue. Most kitchens don't operate under lab conditions. Heat fluctuates, pans get left unattended, ovens and stovetops vary widely, and that means usage behavior plays a major role in safety. Not all cookware is manufactured equally. At the lower end of the market, production costs are reduced wherever possible. Thinner materials, lower durability coatings, less rigorous quality control. And while most products meet basic regulatory standards, durability becomes the real issue. Because when coatings degrade through scratches or wear, performance changes. Food sticks, surfaces break down faster, and replacement becomes frequent. This is where consumer choice becomes important. Not all cookware is designed for the same lifespan, and not all materials behave the same over time. Across the world, many home cooks and professionals are returning to older materials, not because of trends, but because of reliability. Cast iron, used for generations, known for durability and heat retention. Stainless steel, common in professional kitchens, stable and long-lasting. Carbon steel, a balance between strength and responsiveness. And ceramic-based coatings, a newer category marketed as an alternative. Each material comes with trade-offs: weight, maintenance, cooking technique. But the shift reflects something broader: a growing interest in understanding what our tools are made of. The fry pan is one of the simplest objects in the kitchen. But behind it sits a long and complicated industrial history, one shaped by innovation, by chemistry, and by questions that continue to evolve. What we choose to cook with ultimately reflects what we choose to trust. At Stateside Ledger, we believe informed decisions start with understanding the full picture. If this investigation gave you something to think about, subscribe for more stories that explore the systems behind everyday life. I'll see you in the next one.